Hi, I'm Colin Walls, and as usual I'm here to talk about embedded software. Today I want to talk about inlining of code. This is a compiler function which is used everywhere, but I think is particularly interesting to embedded developers. The idea is quite simple. Normally, when you call a function, you have one copy of the function and each call site consists of a call instruction which leads to the function and then a return. And you can have as many call and returns as you like, but just a single copy of the function code. That's quite straightforward, completely standard. Now, the alternative would be to, instead of having one single copy of the function, is to create an inline copy at each call site. Now, there's a couple of reasons why you might want to do that. One is you've only got a single call to a particular function, and that function's a static function, so you can guarantee there won't be calls from anywhere else, in which case you can simply eliminate the call return sequence and tidy things up a bit by making the code inline. The other possibility is you simply want the code to be as fast as possible, and eliminating the call return will speed the code up, possibly increasing its size in the process. Now, this can all be done automatically by many compilers, particularly if you tell them to compile for speed rather than size. There is a keyword. It was in the C++ language originally, and that keyword is inline. And this enables you to request that a function is inlined. It's found its way into the C language now as well. Now, there is an alternative way of doing this in C++, a sort of shorthand method. When you create a class and you incorporate in that class some member functions, you can just put a reference to the function and put the code elsewhere. That's very common. But if you actually include the code inside the definition of the class, then this is a shorthand way of saying inlining this might be a really good idea. So that's the general principle of inlining. It's well worth looking at. Remember that if you inline a function and then call it many, many times, your code size will gradually increase. Similarly, if you try to inline quite a large function, the benefits might be offset by the drawbacks of the significant increase in code size. Embedded developers are always interested in the balance of optimization between performance and code size. These are both parameters that matter and tend to be a trade-off between the two, and inlining is a really classic example where that trade-off occurs. So that's it for today. I'll be back soon with another embedded software topic, and I'll see you then. Bye for now.